We are one step closer to answering the age-old question, are we alone in the universe?
Dr. KAKU, I am very excited to talk about this. The discovery of an Earth-like planet a mere 4.2 million light years away. How big of a deal is this?
This is a game changer because astronomers have hit the jackpot. This is their dream come true. A new chapter in astronomy has opened up.
Astronomers have just made an unexpected discovery on the dark side of Proxima Centauri B, a side that has long been shrouded in darkness, never seeing the light of its star. For years, we believed this side to be a cold, lifeless shadow. However, recent observations are revealing something entirely different. Faint yet unmistakable signals are emanating from the darkness. As scientists delve deeper into the mysteries of Proxima Centauri B, they are uncovering emissions that are unlike anything we've encountered before. These signals, though subtle, are distinct and could represent a groundbreaking finding in our quest for extraterrestrial life. The emissions could manifest in various forms: artificial light, heat radiation, or other types of electromagnetic radiation, such as infrared. Unlike the constant glow of a distant star, these signals possess a unique signature that suggests they may be man-made or the result of a sophisticated system. Powerful telescopes like the James Webb Space Telescope, JWST, are designed to detect such faint emissions. JWST is particularly adept at spotting infrared radiation, the very type of energy that might be escaping from Proxima Centauri B's dark side. But what if these emissions are not merely lights? What if they hint at something even more intriguing? Could these signals tell a story we have yet to uncover, one that points to a hidden civilization or a mystery far deeper than we could have imagined? Implications for inhabitants. How could the emissions from Proxima Centauri B's dark side help us learn about the planet's inhabitants, if any exist? The faint emissions could be more than just signs of energy use. They might be a key to understanding the planet's potential inhabitants. If these emissions are indeed artificial, they could indicate a technologically advanced civilization. The specific patterns of light and heat could reveal the type of technology in use, the scale of energy production, and even hint at the social structures of the planet. Imagine how Earth's city lights tell the story of our political boundaries and social conditions. A densely lit city reflects economic power and political priorities, while dimly lit areas might indicate poverty or lack of infrastructure. Similarly, emissions from Proxima Centauri B could reveal an entire civilization's values and priorities through their energy use. Could the dark side of Proxima Centauri B reveal more than just city lights? What if it shows us an alien society in action, how they govern, their technological advancements, or even their struggles? These faint signals may offer us our first glimpse into an entirely different way of life, light years away. Tidal locking and its impact on emissions. Tidal locking profoundly impacts the emissions on Proxima Centauri B. Since the planet is tidally locked, one side always faces its star, while the other remains in complete darkness. This means that the dark side, unlike Earth's night cycle, never sees sunlight. It remains in constant shadow, becoming extremely cold and inhospitable without a source of heat or light. Given the perpetual darkness and extreme cold, artificial lights would likely be essential for any life that exists there. These lights would not only provide warmth, but also illumination, making the dark side habitable. Without these artificial energy sources, the dark side would be too cold and dark to support life as we know it. The unchanging nature of tidal locking creates a consistent pattern on the dark side. This could mean that the emissions detected from the dark side would be steady and predictable. In fact, astronomers might be able to detect these artificial emissions, revealing how much energy is being used to sustain life on that side of the planet. Future telescopes like JWST and the proposed Large Infrared Telescope, LIR, are designed to detect incredibly faint emissions, signals that could reveal the existence of extraterrestrial life. These advanced instruments are equipped with technologies that allow them to capture narrow bands of light, particularly in the infrared spectrum, which is critical for identifying artificial emissions. Unlike the natural starlight that floods our observations of distant stars, these faint signals could be distinctly different, making it possible for astronomers to pick up on something far more exciting: artificial light. What sets JWST apart is its ability to focus on very specific wavelengths of light emitted by artificial sources. The infrared sensitivity of these telescopes means they can detect the heat radiating from a planet, even from light years away. This is crucial because the artificial lights that might illuminate Proxima Centauri B's dark side could emit heat detectable through this infrared lens. By analyzing these wavelengths, astronomers can differentiate between natural starlight and the unique signature of artificial light. The technology behind artificial lights, the potential to detect these faint emissions, could mark a groundbreaking shift in our search for life beyond Earth. We are on the verge of discovering not only new planets, but also potentially signs of intelligent civilizations. The technology behind JWST and LIR could help us spot a civilization on a distant world simply by detecting a pattern of light unlike anything we've ever seen before. But there's more to consider. What kind of technology would be required to create these artificial lights on Proxima Centauri B? The implications of this discovery extend far beyond merely detecting emissions. They could reveal the technology that allows life to thrive in an otherwise inhospitable environment, making the dark side of Proxima Centauri B habitable. Extraterrestrial civilizations would need to rely on advanced technologies to generate light and heat. One possibility is the use of photovoltaic panels, solar cells that convert sunlight into electricity. Although the dark side of the planet doesn't receive direct sunlight, these panels could be placed on the permanently sunlit side, harnessing solar energy and storing it for use on the dark side. Other advanced energy sources might include nuclear fusion reactors, which could generate vast amounts of power without relying on solar energy, or even something like artificial photosynthesis, a technology that mimics the process plants use to convert light into energy. These artificial lights would serve two key functions: to provide light and to warm the dark side, making it livable. Just as Earth relies on electricity for everything from streetlights to homes, Proxima Centauri B's inhabitants could depend on sophisticated lighting systems to illuminate their world and maintain a habitable temperature in the constant shadow. Could these artificial lights be an indicator of something much larger? Perhaps they point to an advanced technological society. The lights themselves may not just be a survival mechanism. They could signify a civilization with remarkable energy management and engineering capabilities, as well as the ability to control their environment on a scale we haven't yet imagined. The very existence of these lights could suggest that Proxima Centauri B's inhabitants have mastered technologies that, to us, might seem like science fiction. Challenges in understanding emissions. While emissions from the dark side of Proxima Centauri B have been detected, the challenges in fully understanding or analyzing them are significant. First, the vast distance between Proxima Centauri B and Earth makes it extremely difficult to isolate the faint signals coming from such a distant world. Even with the emissions we've detected, their faintness could make it hard to distinguish them from background noise. Proxima Centauri's solar flares and cosmic radiation further complicate the task, potentially interfering with the clarity of the signals we're trying to study. However, advancements in telescope technology are pushing the boundaries of what's possible. Instruments like JWST and future telescopes like LIR are designed to focus on specific wavelengths of light, including the infrared emissions that could originate from Proxima Centauri B. These instruments are incredibly sensitive, and with their help, astronomers can isolate these emissions with greater accuracy despite the distance and interference from cosmic phenomena. Could Proxima Centauri B's natural emissions confuse scientists into thinking the planet is just another barren rock? Despite the breakthroughs in detecting emissions, it's still possible that what we've identified is just the beginning. With the right advancements in technology, the real story may yet remain hidden beneath a layer of cosmic noise. While emissions from Proxima Centauri B's dark side have been detected, it's possible that some of these signals could be natural phenomena, not artificial lights. Earth itself provides examples of such emissions, like the shimmering auroras caused by interactions between solar wind and our magnetic field. Proxima Centauri B's volcanic activity, or atmospheric phenomena, could produce similar glowing emissions. In fact, the planet's unique position and environment, constantly facing its star on one side, could lead to dramatic volcanic or geothermal activity, releasing heat and energy into the atmosphere. This complexity could make the task of distinguishing between artificial light and natural emissions particularly difficult. Just as auroras here on Earth can sometimes appear bright and otherworldly, volcanic lighting or intense storm activity on Proxima Centauri B might give off emissions that could be mistaken for a city's glow. The faintness and irregularity of these emissions might cloud our understanding of what's really happening on the dark side. The role of the atmosphere. Could Proxima Centauri B be hiding something under its surface? What if these emissions aren't from a city, but from a planet teeming with volcanic activity? The mystery beneath the planet's surface might be far more complex than we ever imagined, suggesting that the dark side of Proxima Centauri B could hold more than just a few lights. It could harbor a dynamic, ever-changing environment. Proxima Centauri B's atmosphere could significantly influence the emissions detected from its dark side. If the planet has an atmosphere, it could act as a filter, altering or absorbing certain wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, some of that light might be absorbed or scattered by the atmosphere, making detection much more difficult. The composition of Proxima Centauri B's atmosphere, whether it's rich in gases like carbon dioxide, nitrogen, or even exotic compounds, could change how the light behaves as it travels through it. For instance, certain gases can absorb specific wavelengths of light, which would alter the light's spectral signature by the time it reaches our instruments. This means that even though we might be detecting something from the dark side, we might not fully understand its true nature without considering how the atmosphere has affected the emissions. What if Proxima Centauri B's atmosphere holds the key to understanding how emissions from its dark side could reveal the planet's history? The way the atmosphere filters these emissions could provide insights into the planet's past, how it developed, what kind of environmental changes it has undergone, and whether it is capable of supporting life. By leveraging the power of next-generation telescopes like JWST and LIR, we are on the brink of unlocking profound discoveries. These instruments could reveal faint emissions from Proxima Centauri B's dark side, potentially unveiling signs of life or technology in a distant world. With these breakthroughs, we will not only answer questions about the planet's habitability, but also open the door to exploring what could be an entirely new chapter in our search for extraterrestrial life. The future of space exploration is exciting, and with each advancement, we get closer to discovering whether we are truly alone in the universe. These discoveries will change everything we know about the cosmos, and we are standing on the edge of something monumental. If you enjoyed this journey into the unknown, don't forget to like and subscribe for more updates as we continue to explore the mysteries of the universe.